All right. Hello, everyone. My name is Oda, and I work at NASA's Jet Propulsion Laboratory in Pasadena. So just across the 210, about an hour from where y'all are, just about. And I work in the education office, and my job is to help teach kids like you about things we do at NASA. So I'm going to talk to you a little bit today about careers we do that there are at NASA and things that you can do with different types of education and how you can prepare today. I want to start off first here with video, and this little video is going to kick me over to YouTube real quick. So I'll show you a little bit about what we do at JPL.
The long-range purpose of unmanned exploration of the planet is the development of technology which will lead to eventual manned exploration. Power, go. Systems, go. Propulsion, go. Avionics, go. Flight software, go. Scientifically, our objective is to assist in answering two basic questions. What, if any, life forms exist on the planet, and how has the solar system been formed? Telecom, go. Fault protection, go. Uplink, go. Phase lead, go. 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 Go.
All right, so that gives you kind of a little window into what we do at JPL. You probably noticed that we do a lot of robots. And so all the NASA centers do different things. There are 10 NASA centers across the US. You might have heard of Houston from some of the movies. Houston, we've had a problem. Houston is where the astronauts train, and we do some like plant research for the International Space Station, which is orbiting Earth every day, several times a day, once every hour and a half or so. And there's astronauts up there all the time. And then you might have heard of Kennedy Space Center in Florida, where we launch our rockets from a lot of times. And there are several NASA centers around the nation, 3 in California, as a matter of fact, and we're one of those, NASA's Jet Propulsion Laboratory. And we do robots. We do robots that explore the solar system. So you might be familiar with the Perseverance rover that is on Mars. That's the one you're seeing on the right-hand side here. The Perseverance rover landed a few years ago and is driving around doing all kinds of interesting research on Mars. It's kind of like a geologist on Mars. We want to learn about Mars because we think when Mars and Earth were both formed that they looked a lot alike, that we think that Mars had a global ocean. And now Mars is like a desert. We know that there has been flowing water on the planet, but there's not flowing water now. There's some ice. There's these things, it's kind of a weird thing called slope lineae, which is a weird word, but it's in the spring we see these little lines form, and we think those are flowing water, like kind of little landslides. So we know that there was water and there's a little water left, but what happened to the water? And if the water disappeared on Mars, how is it that we still have water? And are we headed the same direction, or is there something different about the two planets? And also, water is necessary for our lives and the lives of most everything we know about. So was there life on Mars at some point? And so that's kind of what we're looking for. We want to know was there life on Mars? So Perseverance rover, you can see on the left here, this animation of a helicopter. That's the Ingenuity helicopter. If you look closely, you can see the Ingenuity helicopter in Perseverance picture. It's kind of small, but it's right there. And this helicopter rode out with Perseverance, and it flies around, and it's the first helicopter, the first aerial flight on another planet. And we're up over 60 flights now, and it was only designed to do like 4 or 5 flights and be done, but it's still working, so we keep doing it. So that's one thing you've heard of. Something you might not have heard of is all of our Earth science missions. These are a whole bunch of our Earth science missions, and it's not even all of them. We have a whole bunch of Earth science missions. These are satellites, so robotic satellites that orbit Earth and observe Earth and report down the science. So things like sea level. You might have heard of sea level rise. We know that from some of these satellites. We also have some gauges on the oceans. We study ice, we study land, we study all kinds of stuff, global temperatures, we study clouds, all these things we study from space, because it's good to study things from the ground, but when you go up in space, you have a global picture, and it gives us a better understanding of our Earth as a whole system. You might have also heard of the James Webb Space Telescope, or maybe the Hubble Space Telescope. We also do astronomy type stuff. So on the right here is a picture of the James Webb Space Telescope, and on the left is a picture of an image that the James Webb Space Telescope took using an instrument that was built at JPL by some of my colleagues. And those are interesting galaxies, the things with little spikes coming out of them are stars. And these are very, very far away, things that have never been imaged this well before. So we learn about our universe using telescopes. And all of this is to help us better understand Earth and how we came to be. Something that you will hear about very soon is, if you haven't already, is this mission. This is the Psyche mission. The Psyche mission is launching next week. I think the current date is October 12th that it's supposed to launch. And if you happen to be viewing this afterward, you can say, hey, I watched that, maybe. So it's launching on October 12th in the morning from the Kennedy Space Center, and it's going to be heading out to an asteroid. The asteroid's named 16 Psyche, and they just named the spacecraft after the asteroid. And we think this asteroid is made of a lot of metal, and that's unusual. Asteroids are usually kind of like rock, mostly rock with some metal. We think this is mostly metal with some rock. And scientists suspect that this asteroid might not just be your everyday run-of-the-mill asteroid. They think that it used to be the core, or it is the core of a planet, that somehow the planetary material on the outside, the mantle, got stripped off in maybe a collision or something, and all we're left with is this core. And so we're going out to find out if that's the truth, because we have cores, like Earth has a metal core, and other terrestrial planets like Mars has a metal core, but we don't know a lot about these cores because they're so far down, like we can't drill that far. And so we're going out to Psyche to see an exposed core of a planet, we think. And that will help us understand our planet better. Like how does the core affect our planet? We know some things, but there's a lot we don't know. So keep an eye out for that one. So lots of stuff goes on at JPL. We have all sorts of different jobs. And I want you to understand that you could work at JPL if you want to. It's just a matter of following your interests and whether your interests align with what we do. And we don't just have technical degrees or technical jobs. I'm going to talk to you also about some of our non-technical jobs. So when I say technical, I mean STEM degrees, science, technology, engineering, mathematics. And also in those STEM fields, we have skilled trades. So you don't necessarily have to go to a four-year university and get a STEM degree, although that's helpful. If you are like, I'm probably not in it for college, I'm like not so good at sitting around taking tests and that sort of thing, go to a technical school and get a trade. So like in the bottom left here, you see some trades noted. They like an electrician. We hire so many electricians because somebody's got to wire our spacecraft, right? The clean room technicians we have these places where we build the spacecraft inside these giant rooms. And the people who build the spacecraft are usually not college grad, PhDs in science or engineering. They are people who are very good at following the schematics, the drawings, and the instructions that have been determined in the build of the spacecraft, and they actually put the things together. So those are clean room technicians. There's also something called a spacecraft blanket tailor. Spacecraft, you'll often see they have like metal things on the outside. I'm going to pop back here. You can see a little bit, it looks like kind of aluminum foil in a couple of places on this Psyche spacecraft. That's not aluminum foil. That's actually a blanket that is sewn on, and it protects the spacecraft from radiation and micrometeoroid debris, which is like little rocks that could penetrate the spacecraft. And each spacecraft looks different, so we have to sew these things up special for each spacecraft. So we hire people who are like seamstresses and tailors to do those things. There's something called computer-aided design, or CAD. Sometimes those folks have college degrees, sometimes they don't. And computer-aided design is basically drawing technical drawings, schematics that help people build your spacecraft or understand what your spacecraft's supposed to do. And then machining is taking a piece of metal and making spacecraft parts. We don't go buy our spacecraft parts at like Home Depot. No offense to Home Depot, but they don't carry spacecraft parts. We might be able to buy some nuts and bolts from them, and we would, but we have to machine our own spacecraft parts because nobody sells them. And so we have to have people who know how to do that. And that's not a college degree thing. That is something you go and you learn at a trade technical school or as part of an apprenticeship or something. But we have all these other degrees. If you want to go to college, you can go into engineering, which is the kind of the science of figuring how things work and making things work. If you like to work with your hands and you like to take things apart, put things back together and see how they work, maybe engineering is for you. We have mechanical engineers, we have electrical engineers, chemical engineers, robotics engineers, and then systems engineers who kind of like make everything work together. In the science world, you heard me talk about Earth and climate science and astronomy, so astrophysics. But when we look at Mars and we talk about how Mars is different from Earth, that's called planetary science. When I was your age, I had no idea planetary science existed. If I did, I probably would have done more planetary science and geology work in my life because I think it's really interesting stuff. There's also materials science, which is the science of figuring out what materials we should build a spacecraft out of, because you can't just build it out of any old thing. Some things are going to be harmed by the environment more, depending on which environment you're going to, and some things might be too heavy. So you want to go for lightweight. Anyway, there's a whole science of figuring out what materials we build things out of. You've probably heard of computer science. Programming. Information technology is along the lines of the computer science, which is kind of just when you talk about the larger scheme of managing information. There's also software engineering. So if you're a software engineer at JPL, there's a couple of different things you might be doing. You might be working on websites, but you also might be figuring out the code that we're going to send the commands to Mars, send to the rover on Mars. Those are called flight software engineers. There's also cybersecurity. You've probably maybe heard of that. It's how we keep hackers away from destroying the stuff we're trying to do. You might have heard of artificial intelligence and machine learning. There's all kinds of stuff like you've heard of ChatGPT, that sort of thing out there, but we're doing artificial intelligence on our rovers so that they can drive by themselves. They can look at the landscape. We say, okay, we want you to go here sometime today, and they figure out, oh, I got to go around this rock. I got to go around that rock. Oh, that's too far of a dip. We don't want to do that. And it's all artificial intelligence. So it's kind of cool. And then, yeah, I mentioned the web design stuff too. My degree happens to be in mathematics. My undergraduate degree is in mathematics. I have a PhD in environmental science. So I'm a mathematician and an earth scientist. There's all sorts of data that comes back from our spacecraft. So we get more data back from our spacecraft on any given day than we can analyze in a year. So we have to do all sorts of algorithms with computers, and we need lots of people who can analyze the data. And some of those people work at JPL, some of them work at other companies, some of them work at universities, but there's lots and lots of data. We're currently analyzing data from like 10 years ago. And we're of course analyzing current data, but we're still catching up from long ago because we don't have as many people as we need to do all that. And then if you're trying to get a spacecraft out to Mars, you have to design the path. You don't just like drive in a straight line. It's a whole bunch of math and physics, but it's an orbital thing. If you're like, okay, I'm so not into STEM, it's not my thing, that's okay too. There's lots of other stuff out there to do. If you are a business-minded person, you like money, we have to we all have to work under a budget, and I rely heavily on my financial person in my office to make sure that I don't go over budget on things, and that if I don't underspend, that I can just spend on target. We do business contracts, all sorts of organizational support. Anytime you see a video, like I showed you a couple videos, somebody produced that at JPL. So there are video production people. Anytime you read a news article, somebody wrote that. So there are writing people, editors. You might expect that we would get a lot of attention from the media, like news organizations. We have people at JPL who specialize in media relations. So when the news says, hey, we want to come and interview somebody, we invite them on and we make sure that they get the interview that they need. We've got social media specialists, we've got graphic designers. The list goes on. I mean, I'm in the education office. I develop lessons for the classroom. We have interns in the summer. We work museums. There's also, we have a whole library system at JPL. My librarians are amazing. Anytime I need to find anything, any research on a topic, I contact the library and they send me all sorts of great stuff. We have somebody who's a historian. They keep track of all of the things for historical archives. Somebody takes all the pictures. And then we're kind of like a little city. We have law enforcement, we have fire protection, we have maintenance operations, we have 3 cafeterias. We've got an amazing landscaping crew. Oh my gosh. If you ever get to come to JPL, one of the most fun things is how beautiful our campus is. And it's because of our landscaping crew. They find all these weird, interesting plants and trees that many of them are native to Southern California, but some of them aren't, but they can live in Southern California without a lot of water. And they make the place just so beautiful. So there's just lots and lots of stuff. Human resources, just people who do the hiring and the firing. And of course the safety office that makes sure that nobody is getting hurt on the job. So lots and lots and lots and lots of jobs. These are just like the tip of the iceberg. And we're always looking for young people to come work with us and inspire our work further. So right now, what can you do if you are in school for now, the best thing you can do really is study and become good at your subjects. And I'm not talking about just STEM topics, any of your subjects. One thing I try to tell people is if you could be the smartest person on the planet in one subject, like maybe you're the best math student ever, but if you can't explain what you're doing, if you can't communicate and talk about what you're doing, it's a real hindrance to your colleagues when you're working. You need to be able to share what you're doing. You need to be able to write about it and talk about it. So studying, basically. If you're interested in STEM stuff, join STEM clubs. If you're not interested in STEM stuff, join other clubs, because that's how you'll get more out of school than you get in the classroom. And then the number one skill that we are requested, that our mentors request of interns, is coding. So learn how to do some coding. There's lots of free places online. You can, there's like Hour of Code, code.org, Khan Academy. I mean, we don't sponsor any of these places, but they're all free, and you can learn how to code. There's even some things on YouTube. There's even some apps that teach you how to code for free. You should check it out if you have any interest at all in like developing games or anything like that. It's pretty fun. When you get older, junior year and senior year in high school, you can add looking for internships. There are lots of places that have internships, even if it's not us, that would prepare you for internships with us. And then when you get to college, we definitely have internships for you. And then as you go into adulthood, don't think that you're ever going to know everything, because none of us do. Always keep a mindset of wanting to learn more, and never stop learning, because that's what keeps your brain sharp. And that is what I have for you today. We have a lot of opportunities at JPL, a lot of interesting stuff, and I would love to take some questions if you have them.
So Oda, one question we have is like, what got you interested in going to JPL, like in that field?
Yeah, good question. So when I was a kid, I didn't know anything about NASA. There's lots of people you'll ask the same question of, and they'll be like, oh yeah, well, I was in second grade and I watched some spacecraft launch on TV, and that made me want to be an astronaut or something. I had no clue. I mean, sure, I saw some things here and there, but I honestly didn't think that it was something for me. I grew up in kind of the boondocks in Central California, in the middle of nowhere, in a little farm town. And my family didn't have a lot of money. I thought, they told me I was going to college. I'm like, okay, sure, whatever. And I just did good. I did well in school. I'm like, whatever, that's fine. And then I graduated high school and got a college scholarship. And then I was filling out my college application, and it asked me to declare a major. I'm like, what is that? I had no idea. And they're like, well, pick something you're interested in. I'm like, oh gosh, I don't even know what I'm interested in. Mm-hmm. And so I'm like, well, I guess I'm good at math. And so I picked math. And so I got this degree in math, and I had figured out that I was pretty good at teaching. And I part of my putting myself through college was tutoring kids in math. And so I got a teaching degree, and I taught high school math for like 11 years. And then I thought, you know what, I want to go get some industry experience and figure out what else is out there. And then I want to come back to the classroom so I can bring more of industry experience back to the classroom. And a long story short, I found a summer workshop that was at NASA for teachers, and I signed up. And at the end of the 2 weeks, one of the people in the program came up to me and said, we have a position opening in Southern California, and I think you should apply. And so I did. I didn't work at JPL at the time. JPL is actually my third NASA center. I worked out at NASA Armstrong, which is in Edwards, California, Edwards Air Force Base, and the Mojave Desert. And then I worked for 3 years in Houston at the Johnson Space Center in Texas. And then I worked came back to JPL, and I've been at JPL for too many years. But that's kind of how I ended up. I always had planned to go back to the classroom, but then when I found a job where I could still work with teachers and kids and actively bring industry, interesting industry stuff to the classroom every day, I decided to stick with it.
And how often do you collaborate with others through either education or through JPL?
Yeah, so I on a weekly basis, I'm working with scientists and engineers at JPL to write lessons that are aligned with what the missions are doing and what teachers have to teach in the classroom. In fact, I just this week I've met with two different groups. One was a group that studies the universe, and we're going to be doing some lessons on a new telescope that is it's actually launching from a balloon in Antarctica. And so that's kind of a trip. And yeah, and then another one was another aerial earth science thing. And then this weekend we actually have there's it's called the NASA Space Apps Challenge, and anybody can participate if any of you are interested in coding. It's a 2-day hackathon. I think it's 2 days, maybe it's 3 days. And it's this weekend, and I have 2 challenges in that. One of them is on the Psyche mission that we discussed earlier that's going to the middle asteroid, and another one is on the SWOT mission, which is the Surface Water Ocean Topography mission, which is an earth science mission orbiting Earth, and we're looking for people to develop visualizations for us. So yeah, and then I have contact with schools on a pretty regular basis too. Is mostly remotely at this point, but do a lot of like emailing with teachers and that kind of stuff.
Yeah, well, the work sounds really interesting. It sounds like it's just a great day to show up to work every day, right?
Yeah, it really is, and that's another thing too that I've seen so many people in life, they just drag themselves to work. Like it's like, oh, I gotta get up, oh, I gotta go to work, oh, I hate my job. And you know what? I've had those jobs. And it wasn't teaching, although some days going to work as a teacher was hard. But I've had those jobs where I was just like, I am not going to do this for the rest of my life.
Right.
And I'm not going to tell you every day is, bubblegum and roses. It's just, most of the time we're doing really good work. Sometimes we have to sit in boring meetings and be frustrated with government policies, but most of the time it's really fun work and we get to
get. It's like it's get the day to day, but then you have the surprises, that the discoveries that are new made, right?
Yeah,
and all that kind of. It's just exciting, I think. So.
Yeah. Well, there's always something to learn, and something I didn't know as a kid about myself. Like 4th, 5th grade, you asked me if I knew this about myself, I'd be like, I have no clue. But now I know I thrive on learning new things. And there's always something new to learn. In fact, I can't keep up. There's so much going on, I can't keep up. And if I had nothing to do at my job one day, imagine that. If I did, I would just sit and read. There's so many interesting things going on. And if I'm at JPL, we have all kinds of interesting laboratories and clean rooms. You can walk down and watch spacecraft being built. And it's really, really cool. Yeah.
That's really cool. That's really cool. Yeah, it's fun. So thank you, Oda. I appreciate your spending your time with us today. I found it interesting. It's like all these different, and I like the way you have all these different jobs that are needed by JPL, and not just college bound, but for college and career, right? So it brings everything together, and there's a job for everyone, I think, at JPL, which is great.
Yeah, absolutely. We're like a little town.
Yeah. Fantastic. So anyway, thank you very much, and appreciate your time with us. So thank you.
All right. Thank you.